Well, yeah, we'll go back and we'll throw down all the pertinent information that we need.
Yeah, because when I was copying it down, I was converting it a little bit different than you did.
Okay. Oh,
I gotta remember what it
can you
was.
take a peek and let me know?
Basically there.
You got like a foot to the left.
And then what do we do? 10%. Yeah.
And I get, oh, you know what? I don't think that I checked over here. I'm not gonna tell.
You're way off.
So C20
Foot to the right.
plus 10%.
There you go.
Yeah. So you'll be
I have stuff erased on step 9, and like I remember something not jiving. I kind of just shut my books and said,
this temperature, but what I'm wondering,
well,
if you wanna to put
it was something the way we took,
for that shit, like we did for our schedule.
because I was using decimal feet. And
Well, none for that, but I mean, as far as.
I remember something was written down different than that.
10 power, like
Just do what he does on the board, don't try and get fancy. Yeah, he was using inch or feet.
You just input your descriptions here with this and then add your.
Why does that look different?
This isn't his template.
Oh,
This is his template.
okay.
But
Are
I'm
you
just
just
saying-
working on the side first, or?
This is my estimate. That's my estimate. This is my
Okay.
estimate with my data. so like that
Oh,
picture
from
turned
before?
in.
Yeah, so,
Does he want like subtasks to the temp power to put in there? Cause he doesn't.
no, so what, like, on 10 power, I mean, bro, I just got 10 power stuff. What really came down was like, that section, so
Like
my
jobs, like
footings,
excavation site, like.
so we have site and we have foundation for
Yeah.
excavation, so we have 2 different
Yeah,
excavations.
me too.
Yeah, okay. Well, we figured out a lot of this from when I was working. Yeah, yeah. So, like my roofing system,
Yep.
you know, that has drip edge, gutters, fascia, shingle, you know what I
He
mean?
wants like all that, like a breakdown like that?
That's what I do. Cause he said, I don't wanna just see roof and then I put the number. He wants, you know, what are the trusses, what are the shooting, what's
How the
the?
fuck do I know?
Remember when I,
I didn't do that, but Marshall did, and where's he at?
So did you?
not my group, bro.
Since I did it,
Okay,
if you could submit it or if you just.
Why can't
So,
I fucking make it?
Marshall won't make it today. He emailed me that he's not feeling well.
Sign that.
So remember that we were gonna try H equaling 12, right? And if we use H equal 12, what did that end up getting our net soil pressure to?
Oh, dude, I'm totally on.
Remember?
Hold on, 2,000 minus 100. If the
Yep.
concrete's 150 pounds per foot, then we take
I did that.
2,000
Okay, yeah, this.
minus the 150, cause it's 1 foot, so you get 1,850.
Yep, and that's what worked out well for that 12 inches, is that changed it to 150 pounds per square foot. So this became 1,850
You wanna take a picture?
Yeah, I think so.
You might want to.
pounds per square foot net. Okay. We figured out that the total load was 5,750 pounds per foot, right? Because we didn't have to factor for our soil pressure. Then we were able to calculate our required footing width.
So that's number 4.
We did that?
That's not what I got.
We did all this stuff?
Total load should have been 8750
I got,
minus
I'm
dead
sorry.
load and,
8,750, right?
Yep.
yeah.
which was, yeah.
Which was,
And required
dead load.
footing with
And that when we
4.75 feet.
calculated that out, it came out to be 4.73, right?
Yeah,
And then we
but
said,
rounded it up.
now we're gonna make things easy. It's gonna be 4 3/4 feet. It's gonna be 4 foot 9 inches. It might be 5 feet, depending on what we're dealing with on the site itself. Okay? We checked our design soil pressure, and remember when we went back and looked, the design soil pressure was 1840. The only reason I wanted to look at that was to point out that we're really close to that boundary, right? Okay, and so that's not something that we would actually do because we don't have enough factor of safety in our capacity. Okay, then we figured out our effective depth,
Has done it.
right? What did the footing effective depth?
It's your height minus your bar diameter divided by
2.
so minus 0.5.
Yep,
So-
Minus your cover.
So H was what was H?
We came up with 8.5
Oh, 12.
inches.
So yeah, okay.
yep. Oh, yeah, that's right, yeah.
So we went to 8.5.
We said for this one, we were doing 8.5, right?
Yeah.
Yep. Because we used the 1 inch bar diameter.
Yep.
This is unformed, right? Or formed?
Unformed because we're dealing with the
We're
depth.
using unformed,
Right.
yeah.
Forms only run down.
So then, yeah,
Size.
so we use the larger factor, good, that's a good statement to make, Kurt, is that we're
That was
dealing
number
with the
5.
unformed face,
Oh, 6.
we're not dealing with the formed
So
face.
I have 6 as 1.2. I have
That
the-
was 5, I added another step.
okay.
Okay, yeah, and then the next step was then we figured out the ultimate stress put back on the footing by the soil pressure, right? And that's where we had to use our factored loads, right? Our 1.2 multiplied by the dead load and our 1.6 by the live load.
Yeah, check soil pressure, that's what I have.
Equals.
1250.
Okay.
WU, use 1.2 times 3750,
Plus
that's 1.6
6.
times 5,000.
Yep,
So 12.5.
Yeah.
12,500 pounds per foot.
What's the W stand for again?
It's it's just weight here.
Weight. Okay.
Yep,
So ultimate weight or whatever.
yep.
Okay.
And then we were able to convert that
Rho D,
to our pressure, right?
that's what that means, pressure, rho D.
Yep.
Rho D equals ultimate weight.
So we had
divided by weight.
2630 pounds per foot. And then we talked about these critical shear and critical bending dimensions, right? And remember that what we said is our critical bending dimension is going to be the distance from the face of that footing to the face of the projected wall, right? And Rush, do you remember what it was that you pointed out
Yeah,
that
I
people could do?
said the W minus the T because where you have the T, so width minus the
Wall. Thickness of the wall.
thickness, thank you, divided by 2. So W minus T divided by 2. And that gives us our bend, right?
Bending.
That gives you your critical dimension for bending.
Yeah.
Yep.
I got 1.417.
See,
And then
I
we
got
also-
2.125. Because
Yeah,
if
then
you
gotta
convert it all to,
minus your 0.708.
where do you get that?
I have no idea, but it's there.
So what I have is our width
Yep.
was 4.75, correct?
Yep.
You figure that out somewhere. Number 4. Minus 0.5 because T is 6 inches.
Correct.
See, that's where we started to differ. I asked if we were going to do decimal feet, and do you want us to stay in inches for these problems?
This would be the same thing, right?
Yeah, but
Because if you use here 4.75 feet,
yeah,
and then if we use here 6 inches and 0.5 feet, right?
yeah.
Okay, so this one would become 25.5 inches. 57 minus 6 is going to be 51. 51 divided by 2 is 25.5, right?
Yeah.
And this would become, oh, let's see, 4.25
1.
divided by 2? What?
Yeah, and
Divided
that
by
gets
2.
2.125.
It becomes
2.125. That's the answer I had.
But then why do I have this?
So 1/8 of a foot is
Well, I don't know where
an
you-
inch and a half,
Maybe the
Yeah.
right? So are those equivalent statements? Does 2.125 foot equal 25 and a half inches?
so
So-
either way we represent the math is fine.
Yep,
Okay.
yep. So yeah,
I
these
do
are,
better in
They're equivalent statements, so as long as you're aware and keeping track of your accounting, regardless of what unit system you're working in, it should work out.
All right.
Okay, as long as you're doing your accounting.
Well, we'll see on the next step.
Then the next dimension we talked about is that critical dimension for shear.
Yeah.
What did we say it was for shear?
You need your max soil or something? VU, whatever that was.
Then you
Distance
Minus
distance from the footing
pressure
face to
times
the
your
projection
critical shear.
of the effective depth from
Yep.
the wall face. Don't know what that means.
Oh,
So-
this is still, okay, I was reading the wrong damn thing.
Remember that our concrete is going to provide shear resistance, right? As the soil is trying to push on this footing, you're going to develop strength out from the thickness, out from that wall based on the thickness of that footing, okay? So your critical dimension, all you do is you take this distance,
D?
sorry, we're looking at the transverse, not the
Right.
longitudinal. Our D dimension,
And minus the bending, right?
yep. Put our D into this place, and then we just take our 25.5 inches and subtract our D. Okay?
Well,
Maybe that's what I'm doing right here.
no, well, wouldn't that be 8.5 minus 2.125? Or wait, 8.5 was in inches, right?
Yeah, it's
8.5 is in inches.
0.71.
Yeah, so
Yep.
8.5,
So that's what I did.
that's what it was. 0.7.
Yeah,
Yeah.
see how I did that, Nick?
Okay?
I'm doing
So that gives us 17.25 inches, or what is that in feet? 1.43 or something?
1.42.
1.42?
So, just so how we represent it,
Yep,
if we did that all in decimal feet, right? And you take D, which is 0.71,
yep,
because it's 8.5 inches, right?
Yep.
So 0.71 feet minus 2.125 feet, you come up with a negative number. Do we represent that 0.142 negative, or did we just turn it positive?
No, you do 2.125 minus.
oh, okay, I see what you're saying. No, subtract this,
We switched ours over to
Distance.
0.125,
Yeah.
0.71.
That's 2 feet.
yep.
Subtract it from,
You wanna set it up like this, you don't wanna run it the other way.
okay,
Right? Because you're never truly gonna have a negative dimension in the field.
that's what I'm saying.
Right.
I was like, well,
Yep.
just because it was shear, I was like, do we,
Yep, no, we look at it as, we're
Yeah.
starting with that larger value,
Yep.
subtract your smaller value,
okay.
okay?
Well, it's that.
Hey, see? I knew I just arbitrarily write that down.
Okay,
Everything
I don't
has a
even know what
reason.
I'm doing.
so now that we know, did we calculate our ultimate shear? Did we get that far, or did we stop here?
We did one more step.
We started on 9, but I think most of us
It's
backed
the
her up
soil,
Yep.
it's the
during that.
soil pressure times
Okay,
your critical
so now,
shear.
remember, that direct pressure being applied on the base of your footing is trying to shear, right? It's also trying to bend, but we have to look at the shear and the bending, okay? And your ultimate bending is going to be that bending moment, okay, our 2630 pounds per feet.
What step was that? The PD?
And then you multiply it by your shear critical dimension. Okay, so Rush, when you asked about whether it's better to work in feet or inches,
I was
yeah,
say you're gonna have to convert that to feet, right? Because that's in how many
correct.
feet?
Yep, that's exactly what I was gonna say is, depending on what your units are, you may have to do some dimensional analysis here. So Rush, if you're working in feet, you're
Yeah.
fine, right?
Yeah,
I'm working in inches though, so I need to convert this data point into
All right.
feet. Everybody see what's happening there? Okay?
I had it written down.
Me too. I had it written down to inches and then we
Inches and
converted
feet.
it times 12 inches over one, yeah.
Yeah, and that's fine,
Yeah.
right? Right, as long as
That's
we're
just,
using.
that's too much work, but we already got enough going on, I'm just gonna keep it in feet.
Okay,
Change that to.
So we're at 34.6.
I'll say, I came up with like 3,700 pounds.
34.6 is what I got.
2.125 minus 0.71.
but remember, this is gonna be in pounds per foot,
Yes.
right? Because we're still dealing with this entire strip footing as it's coming out, right? Okay? So that's gonna be your ultimate shear, okay? So then the check that you need to make is, does the ultimate shear that the footing experience exceed the ultimate shear that the concrete will allow based on its properties, based on what the F prime C is, okay?
So the number 9 exceeds, so,
Now there's another one. Add mine.
what the
So
hell?
remind me, from a numbering standpoint, where are we in our notes? Is this 10?
11.
This is, well,
I added a step.
yeah, so this would be 10, the check would be 10.
Okay.
Does number 9 exceed?
Remember from the very beginning when we started talking about concrete, we have a number of fees that we deal with. For our shear check, this fee is 0.75, not the 0.9 that we were using for our beams, okay? And then our VC equation is simply 2 times the square root of F prime C.
Where did we get the, oh, okay, concrete design,
Concrete design strengths right
F
here.
prime C, okay.
Yep.
And
And. Yep. What did we say it is, 2,000 PSI?
So 2 times what?
Square root of something.
Square root of,
Square root of F prime C, your design strength of your concrete.
what's B?
Times,
Do we add B?
What's that little,
I
8.25.
don't know. It's a new
symbol?
symbol. I can't even tell you, but. Where was B figured out?
B,
That was what we just said, I thought. We're just gonna go
yeah, B,
with
we're just using 12 inches. Okay.
That's the width.
That's H, isn't
Why are we using 12 inches?
Because that gives you 1 foot. That just makes it easy for this calculation.
Okay.
Okay? To calculate it per foot.
it? Were we supposed to know that? Was that given? I'm just trying to look through my notes to like, make sure I can link everything. I'm just not sure if it was given or not.
We laid it out.
Okay, if we did, then.
Example.
Where's that?
Yeah.
Okay, all right, no, I just want to make sure
The
that
beginning here.
this makes sense when I go home,
Yep.
you know?
We're assuming a 12-inch wide footing.
Yep.
Okay.
Yep. Chad?
So do you have all your steps with your notes with you right now that we started on?
Yep.
It's like, question, or step 1,
Mhm.
we wrote down that
H equals
Where we assumed that the H,
That's what it says, BH.
we're assuming here
Yep,
that we're going to use a height of our footing of 12 inches.
okay,
And the reason we did that is then we could figure out how much weight of the concrete is going to be exerted on the soil,
okay.
right?
Alright.
And why that made it work well is if we use a height of our column of 12 inches, now we said that we were assuming we were using normal weight concrete, so 150 pounds per cubic foot.
Yep.
That reduces to 150 pounds per square foot being exerted on the soil. Okay? So that's what that step is. Yeah, I just kind of cut through that one pretty quick.
You need to make a correction here.
Isn't it
D is
8.5?
8.5.
Oh, yes, sorry.
That was what I was
Okay.
Yep,
Just making sure I'm correct.
yep. Nope,
Too
that
many
is
Ds,
correct.
man.
That is correct.
Okay. 27.
Okay? So VC, so your fee VC calculates out to be roughly 6,900 pounds, right?
Error.
Oh, yeah.
Error?
Once I finally
Hopefully not.
stop getting a damn error here, I'll tell you. Thirty. Try that again.
Do we have to keep this in inches? So if we go back to being in decimal feet, is that gonna screw everything up? Or is there just another?
So Logan's question, if you leave these dimensions in decimal feet, remember that this is in pounds per square inch. So you just have to, you'd have to convert this guy to pounds per square feet
All right.
if you wanted to do
I
that.
don't want to do that.
So I think it would be easier for you to convert these dimensions to inches.
All right.
I keep getting 3421.
I got 6,842.
6,842.
What's
Sure.
the process you're typing that in?
Complicated one. 0.75 times parentheses, 2 times parentheses, square root,
I got
Parentheses,
6,842.
times parentheses.
I'm missing, I know it was.
Yeah.
I was missing the two.
Square root.
All these
Small
buttons, there's a lot of
chunks,
parentheses.
square root.
No.
Let me try that again.
What I would recommend, you guys use Excel in your other classes, right?
Sure use.
You can set up functions in Excel.
This is the,
This is so much easier to run in Excel than on a scientific
I don't have a
calculator.
square root button on my computer.
What's that?
Excel does.
Excel has
Type in
all
square.
kinds of its own functions. Equal SQRT, parentheses. It'll return the square root of any value. And you
Did you know that?
can plop this guy,
I'm gonna smack you, man.
you can plop this guy into a cell when you're setting up your problem and just reference back to it every time that you need it.
Yeah, you just make
Yeah.
that formula on the cell and put your number there.
Yep.
It gives you it every time.
Yep,
It'll be in your junk
Error.
folder.
okay.
Parentheses, man.
So, our check
Square root of 2,000. Answer.
is our critical shear for the concrete greater than the ultimate shear that the soil is going to exert? And here we're saying, careful, here's the maximum shear a concrete can take, 6,842 pounds. Here's the critical amount that our soil is going to exert, 3,735 pounds. Okay? So we're good to go. Okay?
How the hell do you get 0 with the line through it, EC is max shear?
Can't equal 0?
Like, why do they
Oh.
say,
This is just the equation for critical shear of a concrete element. Okay? So we could go through and derive this if you want.
no, thank you.
Okay. Okay.
Quick answer.
No, I did that.
Otherwise, yeah, you're just using that number. Okay? Or, sorry, not that number. You're just using that equation. Okay?
So I missed some. Since the VC is greater than BU, we're okay?
Since if your critical amount that the material can take, that's what this number is telling you,
Okay.
is greater than what is going to be exerted on the material, you're good to go. In fact, what you could look at now is, depending on how much greater your ultimate critical is, based on the material, maybe we can reduce the size of this element.
Be great if that was just again.
What's that?
Is there gonna be, I have a feeling like we're
we're
gonna
very
get there
close.
and then, oh my god.
We're very
So
close.
if VC is bigger than VU, we're good.
But what if, so if VU is greater, then we gotta go back and refigure the height?
Yes.
Yeah, then you gotta go back and resize.
That better not
But
be
we don't have to, because we know it will
Yeah, we're good.
Well, yeah, I'm just saying,
But in the future.
I'm imagining our problems, we're gonna go through all this and
So find the minimum,
Or what would something else that would be available to you?
the strength,
Less.
or the design of the concrete.
Well, stronger concrete, right? Because we'd want to increase this value. Okay? So then you could look at 3,000, 4,000 PSI. Okay? The thing that I would caution you against, if when you see these numbers, right? Hey, we should get this number, or I'm sorry, we should get this number closer to this number. Okay? The only way to do that is to shrink your footing. Okay? If we're talking about shrinking our footing, when we think about total cost, how much is it going to cost to get fairly low grade concrete pumped into a hole on a construction site versus figuring out and sharpening our pencils on the amount of steel and installing steel on site? I'd rather pay for the concrete and pump the concrete into the hole, right? Does that make sense to everybody from an economic standpoint? Rather than mess around with placing steel and sharpening our pencil on that one, okay? So,
So you get safety factor.
the other thing to keep in mind when looking to reduce
I woke up this morning and I can't make some mistakes. Yeah.
we want to make sure that we're not reducing our width to anything less than 5 times that wall thickness, okay? Once we start doing that, then we're going to have issues with too much stress, too much bending going on. And just remember that we're determining that width based off the depth, right? Okay?
Width has to be 5 times the wall thickness?
Yep.
Okay.
I'm sorry. No more than 5 times the wall thickness, right?
Okay.
Not no less.
I was sitting there looking at it.
That's gonna make
0.5 and
far
4.
too great. Yeah. No more than 5 times the wall thickness, right? Okay, so,
6 by 12.
yeah.
5 times.
So maybe, still got our drawing there, so. Oops. Okay, so this will be step 11. Okay, so now we can use our capacities to figure out our area of steel, and then we can select the number of bars that we need. Okay, so.
Hey Ben, can we
Yes,
step
sir.
back a second?
Yep.
So at the bottom it says looking to reduce size of footings 5 times wall thickness, what does that mean?
Don't want your dimensions to be more than 5 times that wall thickness. Okay, so,
That's only if VU is bigger than BC?
Correct.
We gotta reduce it.
Yep.
Then that's a check
Yep.
for us to,
yep. So you're just saying, we don't want to get to 30-inch deep, 30-inch wide footings, because now we're gonna have too much stress and we're gonna end up cracking the concrete. Got, so that's where that comes from.
VU is bigger?
Yep.
Then
Yep. Does that answer the question that you have, Justin?
So,
Got. So, our bending moment, so we have to come back to, oh, I erased where we got our 2630 from, didn't I? Oh, no. So we have to take our bending pressure from our soil. Multiply it by that 25 inches, right? Our critical dimension for bending. Remember that? Or what did we say that was equal, those of you that had it in feet? 2.125,
Okay,
right?
alright. So we already figured out.
Okay.
So if we're doing decimal feet, that 1/12 is just to convert it.
Yeah, you don't have to do
Yeah.
that.
The 1/12, I'm just moving it from inches to feet.
Yeah.
Yep.
So this is the moment, so this is not our bending, critical section for bending. What we figured out for bending before is,
It's that middle number, isn't it?
yeah.
2630, right?
and
That's
PD
the
is-
bending pressure that the soil is exerting.
Okay,
Okay?
I have no idea where that 25.5 came from.
that's our 2.125.
That's our critical dimension for bending.
Number 8,
0.75 minus T of 0.5.
so,
He kept his in inches, so it was 25.
Yep.
Two and an eighth.
it'd be like 5588, 5589.
Okay?
For sure.
88.6.
Are you, well, if you're not good,
I mean,
let's stop and
I
figure
see,
it out.
I see the equation here.
Okay,
But-
so remember what it is it's saying that as this footing is in place and the soil is exerting pressure, it's not only going to try and shear that concrete footing, it's also going to try and bend that concrete footing. Okay? And it's going to try and bend that concrete footing over that entire dimension.
Okay.
And so we figured out that dimension as if you take your width of your footing, subtract your thickness of your wall, and divide by 2.
Okay, got
Okay?
it. Yep.
So that's where that number comes from. Okay? Good?
I like
Yep.
feet better.
Yeah.
For real.
So now this is telling us what our total bending moment is going to be. And then if we figure out with the moment, if we put it out at the edge, we can determine what our capacity is going to be, what the maximum bending resistance that we need to have. Okay? So our ultimate will be our 5589, not 5585.
So is this still part of 11?
I guess from my perspective, I would say that it's still part of 11,
I
because
just
here
wanna
we're
keep it
checking
tracked, so
capacity.
if I ask you a certain number,
Yep.
you know where you're.
Yep, I would consider this to be part of 11 because you're checking capacity.
What?
What did you get?
What's the
Bro,
divide by?
Bro,
yeah.
bro, what did you get, bro? There's not anything close to him.
Well, he has to convert it.
Why is it over 2?
Because it's going to be at its maximum at the halfway point.
Oh, okay.
Okay?
Okay,
He has to
so
go back in
I'm
feet.
in feet, because I'm not doing the inches. I'm not doing
Oh,
that.
so you have this in 2.125?
That's correct.
So then your number would be 12 times smaller than mine roughly.
I have
Right?
23,750.
I
I
knew.
got
What?
5938.
You're basically multiplying it by 1.
5589.
Times
Yeah.
2.125. Oh, that's why I did it wrong.
Yeah, if you get 29, you're essentially just multiplying this by 1/2.
I keep getting 5900.
Yeah, that's what,
That's what.
5938.
yeah.
50, yeah.
5938. Yeah, that's what it is.
Pound feet.
Your math.
5930, yeah. So if you take this number and divide it by 12, or multiply what you have by 12.
Alright.
71,259.
Perfect. 1 pound inch, we can split that amongst friends,
Yeah.
right? Okay?
5,938.
So we took the moment. Freaking 11.
Okay? Then you can take your ultimate, divide it by your phi factor of 0.9, and that's gonna give you your bending capacity.
We're always using that .9.
That's that 0.9 from the other lesson.
We're always using the 0.9 when we're checking our capacity when we're doing our steel calculations.
Wasn't the 0.75 what?
This is for when we're doing shear capacity as it's related to soil pressure. Okay, so don't try and memorize when you're going to use 0.9. Write down that reference point in chapter, I think it's in the beginning of chapter 13, where they go over the different phi factors, okay? Or just remember that here you're using 0.75, the rest of the time you're using 0.9, okay? I agree with you. One of the things that drove me batty in reinforced concrete design, there's at least 5 or 6 different phi factors that you have to use based on different scenarios, okay?
Now, is there a check we do here?
7.7.
I'm sure there is.
Like, okay, we found out the
659.
Yes.
ultimate and the tension and all that.
Yep.
Well, I got some.
Now that now that we know the bending moment on our tension face, what did we do with this number? Think all the way back to when we were just doing beams.
7,500.
Okay, so if I make you.
What do we
Figure out
use with
area of
tension?
steel or what?
What do you get?
We've used it to figure out the area of steel.
Yeah.
So that's what we can do next.
79,177.
So is that the square root of
Calculated, so.
Round that up, what do you get?
MT over BD?
That's the one where we have, yeah, so area of steel is gonna equal MT divided by
Still
F prime Y.
Is this a new set?
Sorry, thank you, John.
Ah.
Doesn't have a mutiny right then. This goes past 13. I'm telling you.
Well, I don't think that it will, because the next thing is
Wait.
required spacing.
Is there gonna be an answer to this?
Yes, there is.
It doesn't work.
So that's not how I figured out area of steel.
I wouldn't mind.
What?
That's our equation from our last lesson?
Well, this is rewritten. Remember that we also have the one where we factor out the D?
The D, that's
Yep.
why, okay.
Yep.
We know D.
Yep. Here we know D because we determined it. What?
That's what I get for trying to remember.
I don't do that.
Nope. Ooh, that's
I don't
right.
suppose there's like an automated program that does this for us.
I suppose there is.
If you write it into Excel, it would do it for you.
Gilly, what's that app?
Yeah, I was gonna say, someone get on that, or?
You just take a picture of the math problem and it spits
It
it.
does it for you?
I don't know if that would work for this.
I won't tell you how to do the whole thing without solving your math equations.
What was it, FY over D
Photo
minus A?
It does your formula for you.
79.
website that I use, like,
No.
Photo map?
6,598. Bullshit.
Yeah, so let's take a picture of a formula or equation and it
Yeah.
solves it for you.
And it solves it out?
Yeah.
Interesting.
Shows you the steps.
FY is,
Yep, so remember that FY is 40 KSI or 40,000 PSI, whichever one you want to work in. But remember that we have pound inches up here, right?
yeah, I converted it though.
Yeah, why you keep using inches, Ben?
Stop doing that.
Yeah.
Inches for me is easier because that's what we're talking about with our
I've already gone and converted all.
effective
Yeah,
depth.
But then we have to convert every time.
That's,
Here, just write
how things go
0.71 right by your
sometimes.
effective depth. And now go to feet. So, hold on. Is the 40 KSI, if I'm in feet on top, do I gotta change that?
yes,
Can't use 40 keys.
yep. Because you're gonna have feet up here, but you're gonna end up with inches down here.
So I would divide by 12.
Multiplied by 12.
You would want to inches, you wanna multiply by 12.
So it's 480.
Convert it in number.
480.
11 and be done.
Yeah. KS, T's.
Okay, so 40 KSI. Minus the B.
Then I figured I didn't write down here, sorry, where they got their A value from.
So do we get that right out of the chart then?
Yep,
A over D?
With the D's eight.
well, what's that?
D's 8.5, but we get the other one from the chart.
Yes,
2.125. Right? What was D?
2.12, no, that's your depth, or that's your critical dimension for bending,
Sure.
right?
There are so many numbers in this piece of paper right here, don't there?
I got 8.5 inches is D.
Which is, 0.175. Or 0.17.
And A
0.71.
I'm back to inches now. Fuck this feet stuff.
Oh, okay, yeah, so they assumed, their A value was going to be 0.2, okay? So they assumed under reinforcement, so,
So we don't use 0.685?
8.5.
no,
So we don't use a chart.
no, I would use, for the purposes of this homework,
A equals,
assume A equals 0.2, okay? Just to be consistent with the book example.
So is the D under A the same as the D we're subtracting from then?
Yep. Okay,
So is that 0.2 inches then? What is that 0.2?
that would be inches squared, right? Because we get that from an area, so that it comes out being in inches.
Oh, I'll just erase all this and go
Right?
to inches.
Yep, what inches to be easier.
5,760.
178. 5.
Wait, what?
No, sorry, I'm talking for, if you were gonna use feet, it's 5,000,000.
Okay.
Yeah, no, that's,
760,000 pounds per square foot.
Gotcha.
16,778. Did I do that right? Probably not.
What? So remember, this area of steel, right?
Yeah, not right.
So this is gonna end up being, I mean, this is gonna be a very small number.
233.5. How did I do that?
so that's 8.47 times 40.
Can't imagine trying to learn this online.
So 339.
Right, what are those guys doing?
339 is what I got for the bottom number. So 79, 178 divided by 233.5, 234. What is that?
Aren't you getting 0.23?
Hell?
I have 339.
It's 0.0.
Looks like I'm wrong.
Oh, 0.23?
For the,
I got 233.
8.5 minus
Okay, so let's step through this one at a
0.2
time.
divided by
What's this number?
0.023.
0.023. Oh, okay, you're saying that's what that number is. Okay, yep. Okay,
Okay,
so that leaves this at 8.48,
yeah,
200.
roughly,
pretty much, yeah.
right? And remember, this is in kips, right? So don't multiply it by 40. If this is in pounds, we gotta multiply it by 40,000, right?
So,
That's close.
Okay,
and,
7, 9, there's 3 decimal points off.
Yeah, I had 233.
941 is what I got for the bottom number there. So 941.
Okay, and then if you take your 8.48 and multiply it by 40,000, what does that get you? Should give you 320,000 something, 340,000 maybe. 339,000, right? So we have roughly 80,000 divided by roughly 320,000, right? Just talking generalities. So it should be about 0.25 square inches, right?
Hold on. So 40,000 times 8.48, 339,200.
That's what I got.
300,000,
Yep.
339,200.
Yep, roughly.
Okay. So,
I get 0.005 feet.
0.005 square feet.
Yep.
Yep, yep.
so then.
Right,
Yeah, so then multiply it by 144.
Yep. I got that, yeah.
Okay.
1, 2, 3, 3. Okay, I got that. And that's in inches squared.
That's in inches squared, right?
It's the area still.
Yep.
And that is the rebar,
That's the total area of rebar that you need.
that little.
Yep. Yep, okay. Now, it's just bringing it home, right?
But it said if it goes past 13.
13 is where you figure out based on your different size of rebar, right? Here we are. So right there.
Yeah.
Okay. So the bar sizes I looked at were number 3, number 4, number 5, and number 6. Okay? And if you want to look on page 513, yep. So we're in chapter 16, right? So they set out a table for this example where they gave you, based on this bar size, gave you the area of bar, gave you the area required for bending, the bar spacing required, and then the bar spacing that they selected. Okay?
So we need to pick a bar that's bigger than 0.233?
No, because there's more than one bar, dude.
It's going to be more than one bar, right?
I say it's number 3. So we send it with that. 2 number 3s.
He's done in an hour.
Why don't you re-engineer this for you?
Yeah, well, I certainly don't answer. What's going on there? It's 12.
Wait, are you, are you doing 0.29 or should you be doing 0.233?
0.29's the area required for bending.
Yep. So they've got,
What does S mean?
S is
Size?
your spacing.
Oh.
Okay?
How does that figure spacing?
This gives you area of the
Are
bar.
we talking about bars, like 3 or 2 running on the bottom, or?
We're
Why are you
doing-
using 12 inches is what I'm,
We're looking at transverse. So here we're looking with the height.
Should he be doing
Okay.
So H is what's on top of it.
Yep.
Okay.
I do
What, John?
get what you're saying here.
I just don't, you're doing
Why are
what
we
the
using
book did.
0.29?
Should, we got .233, and the book got .29, so why are we using .233?
The .233 is area steel based on the tensile requirements. Okay?
So is .29 just a constant?
For this problem, it would be. If we went back and determined our capacity based on the
Literally in
bending.
the book,
Yep.
for number 12, they have 0.29 as the answer for that exact equation that we have for number 12. Their answer.
Oh,
comes out-
for their area of the steel?
Yes, it
Okay.
comes out to 0.29,
Gotcha.
where we have 0.233.
And they use .29 as their denominator.
I mean, it's not that far off.
Well, because they have 7.6, not 8.5 as their.
Yeah, they're using 7.6.
Yep. Good point.
So is this not?
Yeah, we gotta use our number.
Yep.
Okay.
Yep, so this has to be .233.
5, 12,
You
5,
catch
15.
there, Vinny.
I have my.
Yep.
You get a cookie today.
Are you buying it? Like one of those big ones we have?
Sure.
So we'll recalculate those.
Yeah.
Doesn't change that much, but enough when you're talking all this kind of stuff.
Well, yeah, especially when you go back to references. Let's see that.
5.7.
Yeah, 5.6.
10.3.
Does that seem right?
And we'll call it 16.0. Just for ease of rounding. Okay, so 5.7 inches. 10.3 inches, and then what did I say the last one? 16 inches.
Let's jump, don't
Okay. And so then I didn't calculate out number 6 because the guidelines that they give you is to use a minimum of 6-inch spacing and a maximum of 18 inches of spacing.
And 6 would have been over 18, would have been probably like 24.
So we know 3's out then.
Yep.
So either 4 or 5?
So picking either number 4 or number 5 bar.
That's the answer.
That's the answer. We just want to select the steel. Okay.
Okay. Wrap it up.
Yes, Jay.
Yeah, I got a quick question.
Yep.
Going like way back, the formula's the 9178 ounce inch divided by the 40 KSI.
Yep.
Yeah, like in the book, it's dividing it by 2.
Mm-hmm.
Like what does that mean?
They're just using it, it's a reduction factor
Okay.
that we don't need to use for the purposes of our calculations.
So
Yep.
don't do that.
Yep, you don't need to reduce for this. Okay?
Number 4 or number 5?
So do you want 1 or 2 problems doing this?
One.
One, I'm
Nice.
gonna go
One?
ahead and go on a limb and tell you I'm probably not gonna be able to complete one.
Okay.
So,
Yes, Justin?
at the end, what exactly are you looking for to determine which ones are?
Shut up, Jamie.
So you can select either your option between the 6-inch minimum and the 18-inch maximum.
It gives us the 6, it gives us the parameters of
Yep.
the.
And typically speaking, what they're saying is you don't want to use less than the thickness of the wall, and you don't want to exceed 3 times the thickness of the wall. But another thing to keep in mind, from a general spacing standpoint, what is this wall going to have in it for reinforcement? It's going to have vertical bar, right? So oftentimes what we'll probably look at is if it works, to space them along the same parameters that we are doing our vertical spacing, that's probably what we're gonna default to, right? Make our iron workers' jobs easier. Does that make sense to everybody?
Screw those guys.
Yeah, here they said bar spacing, so like, is that they're just rounding to the nearest half, or something like that? Or are they saying?
Yeah, so they're just taking, so they got their required, and they're just reducing it down to convenient dimensions. I wouldn't ask that you, I mean, if you want to, certainly go ahead, but.
So out of those 13 steps, the answer is number 4, number 5.
Yep.
I'm just gonna roll with that.
And
Okay,
six-
so
Well, keep in mind, we also, what else did we determine though? We
Yeah.
determined the effective depth of the footing, right?
I
We
was just
determined
like-
what our soil pressure
I
is
was
gonna
looking
be.
for like an end result on what
Yep,
you're looking for.
yep, so the big thing is, figure out what your effective depth is gonna be based on the height that you select, right? And then the amount of bar that you're gonna use, okay?
I wrote it down.
Okay, the last item, so we wanna look at it concrete. I think you guys are gonna like it. We'll see.
yeah,
What's that?
that's all I wanna do now is just go smash them down the concrete.
Next Tuesday, we will break it. And the only reason, we probably could break them today, I just want to do a trial run on my own, just to make sure that the machine's gonna be able to handle them. So,
So is this a different lesson that you're about to start?
yep, so here we're just gonna look at effective length. Rush, it is super short. Super short.
It's only 9.5 steps.
Not even,
Yeah, yeah.
not even.
We'll get through this one next week.
Nope. Nope, we'll get through this one today.
Finish it up on the way to the site visit on Thursday.
No,
Yeah.
we'll get through it today.
You see it?
I'll show you.
That's I got ready.
Well, yeah,
Portable projector on the bus.
okay,
About to sandbag you, man.
right?
They carry
Well-
having an aneurysm.
Hey, you broke Terry, man.
I'll put it this way, if you don't sandbag me, we'll get through it today, okay? So, what we're gonna look at is development length. And so first we need the definition, okay? Oh, goodness.
That's a hell of a damn definition.
What?
That's a hell of a definition. Just keep
Well,
going.
This is just the definition, right?
I don't know. That's,
I guess there's two definitions embedded in it, right? Okay, so development length, so this comes out of the code, ACI 318. So development length is the length required of our steel within the concrete, okay? To develop design strength in the steel at a critical section. Critical sections, remember, that's going to occur at our maximum bending stress, okay? It's also going to occur at points of termination of our reinforcement. Couple examples. Remember early in the semester we looked at uniformly loaded simple beams?
sure.
Yeah, I remember that.
Right?
Yeah.
When I would draw these goofy
I
things,
don't wanna see that again. We already did that.
right? Yeah, no, we're not gonna analyze this, I just want to jog your memory. Just want to rip the Band-Aid off again, right?
Memory dump that.
So, when we're